Ladies and gentlemen, thank you for standing by, and welcome to the Modular Mining Beyond Fleet Management, How Proximity Detection and Speed Enforcement Can Improve. During this presentation, all participant lines will be in a listen-only mode. If you would like to ask a question during the presentation, please use the chat feature located in the lower left corner of your screen. If you need to reach an operator at any time, please press *0. As a reminder, this conference is being recorded Tuesday, March 13th, 2012. It is now my pleasure to turn the conference to Andrew Cross. Please go ahead, sir.
Good morning, good afternoon, good evening, depending on where you're at in the world. We greatly appreciate your attendance. This is our latest in the series of webinars that we've put forth. As with all webinars, we start with a poll question. We've received some feedback that people find these very informative and interesting, and as always, I think this is very interesting results. So of our responses so far, it appears that 50% of people, of you out there, are monitoring speed in your mines, which is good. That'll be one of the two topics we cover today. Additionally, even spread across all of the topics. I'm going to go ahead and close the poll at this time. If you could quickly get your answers in, and I'll close it here in 5, 4, 3, 2, 1. So thank you for attending today's webinar. Our topic today will be how proximity detection and speed enforcement can improve mine safety. Specifically, we'll be looking at these two topics in conjunction with a few case studies, one specifically at Barrick Goldstrike, and additional data that we found very interesting and showing the implementation of speed alert and proximity detection. Our presenter today will be Neil Ferreira. Neil has over 30 years experience in mining, working throughout the world with mines and technology. He is our product manager of fleet management solutions and brings a wealth of knowledge to us. As always, these webinars are the intellectual property of Modular Mining and are not to be rebroadcast or sent out without our permission, though we will make a copy of this available for your perusal at the conclusion of the webinar. So to begin with, I'd like to actually present Modular's perspective on safety. We look at safety as a layered approach with many factors that come into play, not just a one technology solution fit. At the very base of that is individual competency, the miner, the operator himself, his qualifications, his training, and we do keep track of things like training records in our IntelliMine software. Additionally, beyond just the individual competency, you have the shift and crew level, day level fitness of that operator and miner. As in our last webinar, we presented fatigue alert. We view that keeping track of their readiness that shift, that day, is equally important to their individual competency. Additionally, we look at situational awareness, the awareness of the operator of their surroundings, of what's going on around them, including proximity detection, which Neil will be presenting today, as well as Mine Compass and products like Tire Alert, which gives awareness of the tires themselves, and more. Additionally, you have procedural compliance, and that is the tools to track compliance against the standard operating procedures of a mine. We have many products that fit within this space, including Speed Alert, another topic which Neil will be presenting, operator scorecards, fast feedback, which gives you immediate response to when you fall outside those standard operating procedures, and Mine Care. Finally, you have the equipment performance itself. Is it operating in a safe manner? We can track that through several means, including our Mine Care package, as well as our over 100 modular-ready interfaces to OEM and other data sources. At this time, I'll turn the presentation over to Neil, who will be presenting first on Speed Alert. Neil, over to you.
Thank you, Andrew, for the introduction. Good day, everyone. Today we're going to look at two areas of safety that can be addressed by using dispatch. It's speed monitoring and proximity detection. First off, we're going to have a brief discussion around a case study that we did with Barrick Goldstrike. Here we can see an aerial view of their operation. They're presented with some unique challenges, primarily that their trucks end up having to haul downgrade while they're fully loaded. So speed monitoring was of primary importance to that organization. They did do some analysis of incidents and accidents that they'd had on their property, and they found that the majority of accidents involving powered haulage, was the root cause for this was either speeding or proximity to other vehicles, so poor situational awareness for the operators. At the conclusion of the implementation of speed alert and proximity detection, they did notice they've had no incidences attributed to either of those since the introduction of this technology. So, we look at speed monitoring. Why is it important? Where is it important? Obviously, high-risk areas is things that people really want to take note of. Primarily, loading and dumping areas, blind rises, corners, things that you can't engineer out of your design, and other highly congested areas such as workshops or park-up ready lines, whatever you want to call them, right? So, this is all about improving the situational awareness and reducing speed in these very high-risk areas. So, how does this actually work in dispatch? Well, basically, the dispatcher can configure virtual speed traps in the system to monitor speed. So when you've identified where your high-risk areas are, you can create virtual speed traps, and you can move these around different days or different times during the day, so the operators are not aware of their location, just like a normal speed trap that you may encounter on a highway somewhere. The configuration of this is such that you can set a maximum and minimum speeds for your speed trap, and you can simply create a global speed trap where global values are set and apply to all the equipment that comes through there. Or if you want to, you can get a bit more advanced and set up fleet-specific speed limits if your mine policies so dictate. In addition to setting up the speed, you can also set up and configure notifications that happen when a speed violation takes place. And as you can see here on the slide, you can notify the supervisor. If you have the foreman module of dispatch, the supervisor can get notified. The operator can be notified, and obviously the dispatcher can also receive an exception. And it's a mix and match of any combination of these notifications. So how does it really work? So we've set up our speed trap. If we have a look in the graphic here, we can see in the bottom right-hand corner this sort of khaki colored round circle with a dotted line on it. That indicates it's a speed beacon, so that the dispatcher at a glance can see what speed traps he has operational at any time inside of mine graphics and where he has them located, and can choose to move them around. The onboard field computer is constantly monitoring the GPS velocity, and this gets checked against those speed limits that were set up in the initial configuration. When a vehicle arrives at one of these speed traps, we check the velocity, and if the violation is there, a notification is generated, And here we can see notification as it would appear to the truck operator, for instance. So he gets, there's 3 lines of warnings that come up, basically just indicating that there's a GPS overspeed event has been received. There's a custom message appears on the middle line, which you can set up during your configuration as to what message you want to show to the operator. In this particular instance, the message is speeding, slow down, and then there's a system message saying that it's come from the GPS interface, is where we're actually getting the velocity from. So, the operator is now aware that he's speeding and can take corrective action. Right now I'd like to move on to some data we collected from another case study we did with a different client. Here we can see speeds that were recorded over time. We configured speed alert at the mine, but we did not turn on the operator notification. This enabled us to establish a baseline of what was happening at the operation. And we can see here that we've got a speed distribution that's clustered around, with a mean around the 34 kilometer an hour speed. And so we're able to see, where the speeds were actually happening quite readily. So we then turned on the notification to the operator, gave them some training, and then turned on the notification to the operator, and we can see a dramatic shift in the speed, and the speed mean was brought down, or the median of this was brought down to around the 25 kilometer an hour zone, which is what the mine were targeting. So a dramatic shift in speed was achieved after the implementation of this. So having a look at the same case study, but just looking at the frequency of speed events as opposed to the speed. Again, the data on the left-hand side is from the baseline pre-notification to the operator, and we can see that we're reaching peaks of almost 800 speed events happening per shift, which is quite phenomenal. And then post-feedback, we get that dramatic drop-off to below 10 or so speed events, and over time going down to almost 0. So we're seeing here a real positive improvement, a 92% reduction in the occurrence of overspeed events, and obviously the safety around the operation of the powered haulage is dramatically improved as well.
Well, Neil, that's quite a drop-off. You can definitely see where that active feedback to the operators is creating a change. So at this point, before we transition to our next topic on proximity detection, we do have a quick survey out there, as well as just a reminder before we transition, if you have questions, especially if they're on the top of your mind related to speed management, to send them in that chat in the lower left-hand corner, and we'll read them aloud and answer them at the end of the webinar. So we've gotten a few responses in, and a few more still coming in. I'm going to go ahead and close this poll. Looks like just over half of people are witnessing some form of speed-related incidences in their mind. So now we're going to transition to the next topic, which is proximity detection. Neil, back to you.
Thank you, Andrew. So turning our attention to improving operator awareness is what proximity detection is all about. Yeah. I think we've all seen images like this at some time or worse, experiencing the aftermath of such an accident at our mine sites. Not something that we like to see, and obviously we want to take steps to try and improve that. So, I thought I'd take some time to try and figure out, really how big this sort of problem is. And I pulled some stats together, and this is based on information that was available from the in the US and some other sources. And basically, we can see here that in the United States we're reporting roughly 40 heavy vehicle incidents per annum at our mine sites. And this resulted in 6 fatalities on average. Now, pulling out some data from the Parker Bay Company, I was able to extrapolate this into sort of how big a global problem this is. So we're looking at, in the order of 200, on the conservative side, 200 incidents per annum, and roughly about 30 fatalities, which is quite shocking. Now, obviously, we have emerging markets where the incidents are much higher than this, and so we're looking for ways to actually improve what we do with this. So what's the major contributing factor to this? And poor visibility, without a doubt, is the major contributor. Again, pulling some statistics that are available, almost 70% of collisions with powered haulage occurs in the blind areas of reversing equipment. There's other factors that do influence visibility, environmental conditions, rain, snow, fog, dust, those sorts of things that all contribute to this. And, we can see in the graphic that we have on the slide here that, the sight lines that an operator typically would have available to them. And we can see why it is such a big problem. So what is proximity detection in dispatch? It's an automated GPS-based alarming system. So it's a software-only solution. There's no additional hardware that is required to implement this solution in our classic product. The one thing I would like to stress here is that this is about proximity detection and improving situational awareness. It is not collision avoidance. Proximity detection does not prevent accidents from happening. All it does is provide the operator with additional information to help them make the correct decisions about when they're moving into, and as a result, we see a reduction in avoidance. It's no different to having cameras or using a rear view mirror. It's all about being aware of what the situation is around you. So how does it work? We basically set up zones of alarming around the equipment. So this is all configurable, and we work with the customers at the mine sites to determine what the distances of these or the size of these zones should be. So there's basically a warning zone, which we see here depicted by the yellow circle, and a danger zone depicted by the red circle. As the equipment starts to get closer together, we see, everything's still okay. We can see here the green zones are still intact. No problem. The vehicles get a little bit closer and encroach into the warning zone. And at this time, we generate a warning message, an event, to the operator, and we log it in the dispatch database as well. If the vehicles continue to get closer, we then raise a danger warning. So it's a heightened level There's an audible tone that goes off with it to bring the operator's attention that there's something going on, and they need to take some corrective action. On this slide, we can see the implementation of proximity in our Dispatch 6 product. Here we have the Mine Compass on the mobile PTX device, and we can see the equipment truck 111, which is depicted by the little blue triangle there. That's the device that the screen capture is captured from, and we have two pieces of equipment shown, one in the warning zone and one in the danger zone. Down in the bottom left-hand corner of the screen, we see the warning sign there for proximity. It indicates a yellow bar on the left-hand side, indicating that there is one or more vehicles that are in the warning zone on the left-hand side of my vehicle. And similarly, we show a red bar on the right-hand side because there's one or more pieces of equipment that are in the danger zone on my right-hand side. And these warning zones are either in front, left, right, or behind. In this example, it just happens to be left and right, but they can also be in front, in which case you'd see a bar on the top of the warning triangle, or if it was behind you, you'd see a bar on the bottom of the triangle. So like I said, it is designed to improve situational awareness. It provides a visual and audible alarm to the operator, and we are context aware, so we know whether the truck's what type of equipment it is. We know whether it's fully loaded or not, and it's additional information that we can use to provide the operator with enough information to make some corrective decisions. It is utilizing the onboard hardware and wireless infrastructure that's already available with your dispatching system, and we have introduced some smart filters to minimize false alarms. When we did the initial trial of this with Barrick Goldstrike, one of the early feedbacks that we got from the operators were that they were getting a lot of alarms in situations where they didn't need to get them. For example, haul trucks passing each other on a haul route, it's expected behavior. So we introduced the ability to set a speed filter to say, okay, when the equipment is traveling above a certain speed limit, and that's configurable in consultation with the customer, then don't generate an alarm because it's an unexpected situation. Another filter that we added in the Dispatch 6 version of proximity detection is the exclusion by equipment type. Again, feedback from the operators. I'm reversing under a shovel. It's an expected operation. You don't need to warn the shovel operator that there's a truck coming, and you don't need to warn the truck operator that he's close to a shovel. But, a dozer operating around that shovel, even though the operator may expect it, the visibility is not there. He's not always sure where that particular piece of equipment is. So you can still enable that filter if you enable the alarming to happen with that equipment, should you so desire. So, we're using the onboard field communicated computers to do all of the computation. The positions of the equipment are communicated between each piece of equipment in a peer-to-peer fashion. The onboard computer compares its location with the location of the positions that it's received, and also with the configured distances that are loaded up onto the computer. And once they get into those zones, it will generate an alarm for this. So there's no round trips required going back into the dispatch central computer or anything like that. Although each event does get logged at the central, so you can use it later. And we can also, we get the equipment ID, we have all of the locations, we can display all of that information to improve this operator's situational awareness. So, really, what is it about, proximity detection, and why should we be looking at it? Obviously, it's all about lowering risk and removing any potential for having these accidents around you. So one, we can identify risk, we can notify the operator in a timely fashion about that risk, and they can take corrective action to prevent an incident happening. And it's not always just about protecting life. Obviously, that's of paramount importance to all of us, but it's also about protecting the assets. Not all collisions result in injury to persons, but all accidents result in damage to equipment, and this damage can be costly. So just reducing the cost of damage is pretty important as well. And the last thing that I want to say about proximity detection is, because we log all of these events in the database, should you have an incident, you have data that you can go back and examine to try and identify what actually happened leading up to that incident, and you then have documented proof about who was approaching from where and what speeds people were traveling at, and that sort of thing. And this gets away from the sort of the conflicting, well, it was the other guy's fault, he did something wrong. And the finger pointing goes away because the evidence is there logged for you to use in your accident investigations. Thank you, Andrew.
Yeah, so now one of the topics that I found very interesting in reading the case study from Barrick Goldstrike was their implementation strategy really focused on changing the culture. They spoke about how they talked into the breaks and the different lunch times with their operators and the miners themselves, communicating the risks that are involved and making sure that they were taken seriously. And they felt this greatly improved the adoption of this technology at their mine. And I think that really hammered home the point to me and came really full circle back to our original approach that all safety initiatives start with the individual. And so now at this point we're going to conclude our webinar with questions, as we always do. Please keep the questions coming in via the chat feature. First question that came in at the earlier poll question involves Speed Alert. And the question is, what does it take to implement Speed Alert? I am paraphrasing here, at a mine. Neil?
Okay, so this is pretty easy. There's no additional hardware. It is an optional module, so you can contact your account manager to request additional information. But once Speed Alert is licensed, it's a matter of just turning it on and configuring it, and then Speed Alert is operational for your operation for the equipment that you want to monitor speed with.
Sure. And I do encourage you to keep the questions coming in. Here's another one. The IntelliMine system dispatch is most frequently used on the heavy equipment, the haul trucks and the shovels. How are light vehicles handled when it comes to proximity detection?
That's actually quite a good question there, Andrew. Yes, dispatch is designed for heavy equipment, but we do have another product, Roadmap, which is designed for light vehicles, and this uses off-the-shelf PDAs as a solution for the driver, and it is fully integrated with dispatch 6 as well. So roadmap equipped vehicles have proximity detection as a standard feature with all roadmap equipment. It's not an optional like it is in dispatch, but it is fully integrated into the system. So the exact same communication is taking place between the light vehicles that are equipped with a roadmap-enabled device and the heavy vehicles that are equipped with a dispatch device, and they're both participating in proximity detection and generating alarms. So, the equipment operator of the heavy equipment is made aware of the light vehicles, and they show up on Mine Compass as a light vehicle, just like we saw the heavy vehicles earlier. And the heavy vehicles show up on the Mine Compass displayed on the PDA for the light vehicle driver as well. So everybody gets a really good picture of what's happening around them.
Sure. Additional question. What additional traffic load is placed on the wireless network with proximity detection? But I think we can open that up and also talk about speed alert as well.
The wireless traffic is very light. The packet that's going out is extremely small. It's a few bytes in size that contains the equipment ID and the location information. So you don't see a huge spike in load at all. One of the other things that we do to try and reduce this is we introduce what we call peer groups of equipment. So based on the distance between pieces of equipment determines the frequency at which those pieces of equipment communicate with each other. So if you've got a truck that's sitting 5 miles away, it's only going to be communicating with trucks in the load set place, for example, every 30 seconds or every minute, depending on what the configuration is. Whereas equipment that are in close proximity, say queued at a shovel or at the crusher, will be communicating their positions every second. But very, very small increase in bandwidth for this. With speed alert, again, because all of the computation is managed on the device, you see very little. We're getting the arrive notification goes out, which is standard information that's going on, and the response that comes back gets tagged with the additional information. A very, very small increase in traffic.
Thank you, Neil. Also related to communications, do these packages require specific communication capabilities or specific comm network suppliers?
No, this utilizes the standard communication that's already on the mine for your dispatching system. We just piggyback on exactly the same system and broadcast the messages out on that network. So no additional hardware required, no specific communication capability required, or any proprietary communications necessary.
So either our MasterLink network or any of our modular-ready preferred partners for wireless networks will work?
Absolutely, they will.
Great. And we're coming towards the end of the questions. Some of the questions I have not been able to read aloud due to the commercially sensitive nature of them. Do appreciate those that have come in, and we will address all additional questions either in person or in an email. Thank you all again for attending. A copy of this webinar will be made available to you, as well as the case study that we mentioned earlier. Appreciate it. We will have another webinar coming up in about 4 to 6 weeks on our regular schedule, and the topic of the next webinar will be Asset Alert, our new product to manage and monitor light or semi-fixed and fixed assets throughout a mine. Appreciate your time and hope you have a good evening, afternoon, or morning. Have a great day.